We're going to look at graphing rational functions. First, we're going to remind ourselves of the steps to graph rational functions. First, we need to find vertical asymptotes. Vertical asymptotes occur at restrictions on the denominator, which will be values of x that make your denominator equal to 0. Next, we find horizontal asymptotes. My mnemonic device for horizontal asymptotes is this Bobo Botten Eats DC. If you have not watched the video on finding asymptotes, you probably want to do that. So if the power of the polynomial is bigger on the bottom, then we have y equals 0 as our horizontal asymptote. If the power of the polynomial is bigger on top, we have no horizontal asymptote. And if the exponents are the same, we divide the coefficients. So it'll be y equals that quotient there of the coefficients. Remember, if you have no horizontal asymptote because your power on the top is bigger, you will have an oblique asymptote. And to find that asymptote, you will actually do the polynomial division, and your asymptote is the quotient without the remainder. Next, we would find x-intercepts. X-intercepts occur at the zeros of the numerator. Next would be y-intercepts. For our y-intercepts, you let x equal 0 and solve for y. And what you'll notice is you end up with just any constants left. So we'll see that in a second. Lastly, we want to find some additional points to graph. And to do that, we just end up plugging in x values and solving for y. You want to be as strategic as you can when you pick the values because you want to hopefully get some decent numbers to use on your graph. So let's look at a first example. We have here f of x is 6 over x minus 3. So the first thing we need to do is find the vertical asymptote. And the vertical asymptote occurs at the restrictions on the denominator. So in this case, it occurs at x is positive 3. So on our graph, we will just dot in our vertical asymptote at 3. For the horizontal asymptote, we have an x to the 0 in the numerator and an x to the first in the denominator. So it is bigger on bottom, and that's y equals 0. Next is the x-intercepts, and x-intercepts occur at zeros of the numerator. There is no way to make the numerator 0, so we have no x-intercepts. Looking for y-intercepts, that occurs when you let x equal 0. So we would have y equals 6 over negative 3, which is a negative 2, would be my y-intercept. Notice that's not the equation of a line. That's just the y-intercept. So on my y-axis, I have a point at negative 2. And then we would look at some additional points. For our first point, let's go on either side of the y-intercept. So let's see what happens when x is negative 1. When x is negative 1, y is negative 1.5. So I'm getting pretty close there. Instead of x equals 1, let's try x equals 2 next. Get a little closer to that asymptote there. So there we get that if x is 2, y is negative 6. So I'll plot a point there. Then we need a couple of points on the right-hand side of that vertical asymptote. So let's start by checking x equals 4. When x equals 4, y equals 6. And then let's go ahead and see what happens when x equals 5. When x equals 5, y is 3. So I will plot the point 5, 3. If we're not sure, we could even go ahead and look and see what happens when x is 6. When x is 6, y is 2. So you can see it's just going to kind of flatten out a little bit. So then we'll just draw that in. Always a good idea to kind of sketch your graph out before trying to do your answers in ALEKS. Let's look at another one. First, we need to look at vertical asymptotes. And again, the vertical asymptotes are restrictions on the denominator. In this case, it would be x equals 2, right? If x is a positive 2, then that's going to make that denominator 0. And I'll just put that here in my graph. Next, for my horizontal asymptote, notice here my exponents are the same. We have an x to the first in both places. So when exponents are the same, we divide the coefficients. Y is 2 over negative 1, which means y is negative 2. There's my horizontal asymptote. Next would be x-intercept. X-intercepts occur at zeros of the numerator, which would be x is a positive 7/2. And we're talking about the x-intercept, so that's what, 3.5? Then for y-intercepts occur when x is 0. So if we let the x's equal 0, we would have a negative 7 over 2. So negative 7/2, which is negative 3.5. And again, that's a y-intercept. Then we're going to look at a couple of points. Let's look at what happens when x is a positive 1. When x is positive 1, y is negative 5. Then let's go on the other side of the y-intercept and look at what happens when x is negative 1. When x is negative 1, y is negative 3. We know this left-hand side will do that. Looking at a couple of points on the right-hand side, let's check and see what happens when x is a positive 4. When x is 4, y is negative 1/2. And then let's go ahead and put one more in at x equals 5. When x equals 5, y is negative 1. And we know that this side will do that. Remember, we'll get closer and closer to those asymptotes without touching them. Last one. First, we start with the vertical asymptote. Again, vertical asymptotes are restrictions on the denominator, so this will occur at x equals negative 3. And we will put that dashed line here. Next, horizontal asymptote. Here we have the situation where we are bigger on top, so there is none. But remember, that means that we will have to look at an oblique. Remember, for your oblique asymptote, you do the division, and your asymptote is the quotient without the remainder. So for this, our oblique asymptote will be y equals x. And we'll go ahead and dot that in on our graph. So we would have a y-intercept at 0, and my slope is 1. And we're just going to go along the diagonal here. Next, x-intercepts. X-intercepts are zeros of the numerator. Now, if we look at that, we can see that that's not factorable. So we will definitely have, well, not definitely, we probably have some x-intercepts, but since they're not easy to find, I'm probably going to want to try some different numbers. So we'll look at that in a second. Next, we will look at y-intercepts. And y-intercepts occur when x is 0. If you look at the function, if we were to let all of the x's be 0, all that's left is those constants, the -1 and the +3. So that y-intercept is at -1/3, which isn't really a great deal there, right? Oh, sorry, I didn't. Yeah, just really close up there to the x. Now what we're left with is picking some points. Let's pick some on the far left of our vertical asymptote. Let's start by looking at what happens when x is -4. When x is -4, y is -3. Then let's see what happens when x is -5. When x is -5, y is -9/2 or -4.5. So let's go over to the right-hand side of our vertical asymptote and see what happens when y is -2. I'm sorry, I mean when x is -2. When x is -2, y is -3. And lastly, we'll see what happens when x is -1. When x is -1, y is -1.5. We can see that then our picture, our graph, excuse, that's a terrible line. Let's try that again. Kind of follows the edges of that. Sorry, that line is, I'm not doing well with that today. And remember, we chose points just trying to find some things that would work so that we could see the shape and see where our graph was in relation to the asymptotes. I hope you found this helpful.